Nothing like starting things off with a little bit of Brazilian jazz. So today we are going to be talking about drawing a Lewis structure, finding the electron domain geometry and molecular geometry, finding the bond polarity and the molecular polarity, and the predominant type of IMF for xenon oxytetrafluoride. So first, to start it off, we are going to determine the number of valence electrons we have before we draw the Lewis structure. So we'll start by counting the number of valence electrons xenon has, which is 8, plus the number of valence electrons oxygen has, which is 6, followed by fluorine, which is 7, and we multiply that by 4 to get 42 valence electrons. So now to draw the Lewis structure, we will have xenon as the central atom, which will be surrounded by 4 fluorines and an oxygen. And then we'll add all the electrons. And then xenon will have 1 lone pair. Now for our electron domain geometry. Since we have 6 electron domains, it will be an octahedral. And for our molecular geometry, we will have a square-based pyramidal, as one of the electron domains is a lone pair. For our bond polarity, for the xenon-oxygen bond, we have a delta En of 0.1, making it a non-polar bond. And for our xenon-fluorine bond, we have a delta En of 1.4, which is polar, and these values come from our periodic table. And this makes our molecular polarity polar because of the off-balance forces of the molecule. And finally, for our IMF of xenon oxytetrafluoride, we have dipole-dipole because of the strong force of attraction.